So in this example, we're going to have a bit of a combination of the things that we've done in the previous examples, because we've got two words, parallel, and we've got lines. So we've got repeated letters, and we're going to be having letters that are together or treated as one. So let's have a look first. How many arrangements of the letters of the word lines have the vowels grouped together? Well, if I have a look, I've got two vowels, so I'm going to treat I and E as a single unit, and I can write that as IE or EI. So there are two factorial ways to arrange it. Okay, now instead of 5 letters, I've got 4 letters. Okay, so therefore my total arrangements is going to be 2 factorial times 4 factorial, and that's going to be 48 ways. All right. How many arrangements of the letters of the word lines have got the vowels separated? Well, similarly to the previous one, if I just figure out how many total permutations I've got and I subtract the ones where I've got them together, that'll be how many I've got separated. So total unrestricted arrangements is going to just be your 5 factorial, which is 120 ways. I've got 5 letters. And then total ways apart will be minus total together. Doesn't like my handwriting, does it? And that's going to be 120 minus 2 different ways. All right, now we can have a look at parallel. How many arrangements of the letters of the word parallel are possible? Now, it might be easier to actually write all of the letters and make sure that you've got the right number. So I can just see I've got a P, I've got A, R, L, E, and I've got 1 P, 2 A's, 1 R, 3 L's, and 1 E. And then you can just count 1, 2, 3, 4, 5, 6, 7, 8, and I've got 3, 5, 6, 7, 8. I've got 8. It's important that you get the numbers right, so find a way so that you've got all of those correct. Okay, so if I've got repeated letters, I'm going to let that one be N1, and I'll let that one be N2, and my N, which is my number of letters in my word parallel, is 8. All right, so my number of arrangements and remember, it's going to be n factorial over n1 factorial, n2 factorial, so that's going to be 8 factorial over 2 factorial, 3 factorial, and that's going to be 3,360 ways. All right. Now, determine the probability that in a randomly chosen arrangement of the word parallel, the letters A are together. Okay, so that means that my 2 letters A need to be treated as a single unit, okay? But AA is the same as AA, so there's only one arrangement of AA, okay? And now what we're left with is 7 letters with 3 repeated L's. Okay, so this is getting a little bit complicated. So let's start with the things together. So treat the two A's as a single unit, and there's only one arrangement for them. Okay, that leaves n equals 7 with n1 equals 3, and that's my repeated L's. All right, so then what we have is my number of arrangements is going to be my 1 for my A's multiplied by my 7 factorial over my 3 factorial, and that's going to be 840 ways for the A's to be together. Now that's just my number of ways, and it was asking me for a probability. Luckily I know my total number of ways, so let A be the event the A's are together, and I know that my number in my sample space was 3360, and my number in A was 840. So therefore my probability in A is my number in A over my number in psi, and that's going to be 840 over 3360, and that is a quarter. So therefore the probability of two A's together is a quarter.